as you can see here, Common Core, National Council of Teachers of Mathematics, both say number sense is so important, and you need to have place value understanding to develop that number sense, right? Children must gain a really clear understanding of place value. If they don't, things are going to be a real struggle moving forward. What you'll notice in that bottom quote down there as well, it says, recommend that children perform grouping tasks with physical objects, okay? Grouping tasks with physical objects. So they can see and feel things grouped specifically for our system into groups of 10. A way you can do that, a model, one model is what we call the bundle of sticks method. And it looks like a physical bundle of sticks, or you can use pencils or crayons or whatever. Bundle of sticks, and we're going to look at that representation. And then also base 10 number pieces. And those are those little blue pieces that we punched out from your manipulative kit at the beginning. Those are used a lot in elementary education. So what I recommend is that for this video, you get those out, and we'll also look at the base 5 ones again as well. Let's start with this idea of the bundle of sticks method. So a representation, a visible representation, might look something like this, where you have a stick, you have a bundle of 10 sticks, and then you have 10 bundles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 bundles of 10 sticks representing 1 and 10 and 100 respectively, right? So we can see that. And so, children might be asked to represent through this visual medium, say, how do we represent the number 148 using this model, right? And so they might be asked to draw or sketch or move something around, and then see that that might look something like this, right? The number 148. 100, right? So one of those bundles of sticks, 4 of the 10 bundles of sticks, and then 8 individual sticks, right? So 148 would look something like that. What we want to associate is the idea of this number, right? 148, those numerals used in those positions. We want them to see this number and envision this many things. You got to be able to associate the symbols with the pictures. Go ahead, and if you don't have them out, get those base 10 numbers pieces out as well. Again, we introduced those a little bit at the very beginning in the first video. And what we have here are the unit pieces, which represent the number 1, the long pieces, which represent the number 10, and the flat pieces, which represent the number 100. As you can see, they're just a different way of visually representing these bundles of sticks. Rather than actual tangible objects, you have little squares. If you need to go again, right, a bigger number into the thousands, right, we can use one of these, which would be that long flats. Remember, we worked with those back in the very beginning. So this we would call that a long flat, and that would have a value of 1,000. Again, 10 by 10 is 100, and then we have 10 groups of those. So this again represents 10 to the 3rd power, 10 times 10 times another 10. And so what I'd like you to do, if you have your base 10 pieces, use those. If you don't have them, sketch what it would look like. So I'll just give you a number here. Let's say 536. So you're asked to represent the number 536 using base 10 pieces. Give me a little sketch, or use your pieces to just move them with your hands. Go ahead and pause and do that. And what you probably came up with is something that looks like this, right? You have 5 of the flats, 3 of the longs, and 6 of the units. Now, in Blackboard, I also provided a link to an offline site. It's an app that allows you to play with base 10. And the link is there. And what it looks like is this. And this is a great way for you to play around as well. And so what you'll see here is that we've got 3 different columns: units, longs, flats, ones, tens, hundreds. And you can use the plus and minus buttons here to increase or decrease the number in each column, each section. You can also put together groups and take them apart. So I would recommend you go to that app and just play around for a little bit. What it looks like, and you could also turn off the count. So you could say, all right, can I figure this out myself? If I add a few of these groups of 10, I'm just going to put a whole bunch of them, right? And notice you can put them together. Watch what happens when I put together. It took out 10 and it put them over here as a grouping. Remember that minimalist idea? We can even do it again. Put together, shift them over. Now we have nothing in this column. We can do the same thing with the ones, right? We can put them together. We can take them apart. They shift over from one column to the next, take apart. Let's take one of these apart, right? We could take a bunch of these apart. So play around with that app as well as we go through some of these. One other thing that I wanted to point out here, going back to this previous example with 536, you can physically see that we've got 100, 100, 100, 100, 100. We have 5 groups of 100, and it's so important to recognize that's where that number comes from, right? This 500 is the number 5 in this number here. Same thing with here, 10, 10, 10. We've got three tens, which is 30. So there's 3 groups of those sticks. That's where that number comes from. And here, 6 units, that's where that number comes from. So it's so crucial to connect the quantity of groups. Even though it has a value of 500, we state that there's 5 groups of 100, and that's why we put it in that position. Remember that idea of position. Both of these bundle of sticks method and the base 10 pieces are really illustrating the concept of what we call regrouping. Regrouping, which is changing one collection to another that represents the same number, right? Changing one collection to another that represents the same grouping. And that's what I was really doing in that app a moment ago, right? Where I was, right, take apart, put together. Every time I click this button, notice I'll even put the count back up. We have 316 pieces here. Every time I click put together, it doesn't change the count. It just moves things from one column to another. And as long as this put together button is available, I can keep doing it so I don't have the minimal collection. There we go. Now it's gone. This is the fewest number. I can even do it with these, put together, regroup. So regrouping, right, is changing really from one column to another. So let me go ahead and I'll actually do it right here. I'm going to put a representation here that you can see. Let's do together, take part. Oh, I'm doing the wrong thing. Okay, so take a look at the sketch that I have here. of these base 10 pieces. And what I want you to do, maybe get out your own base 10 pieces and determine the base 10 number represented by the collection and sketch the minimal number of pieces that you would use to replace this. All right. So imagine doing that. So go ahead and pause the video, use your own base 10 pieces. Again, sketch the minimal collection, and then what is the number that is represented here. So if you pause the video, then what you probably did, one thing you might have noticed is that there's a group of 10 of the longs right here that we can put together. So we're shifting those over to here. In the ones, in the unit section, we've got 12 of them. So if we put 10 of them together, shift them over here, now we have got our minimal collection, and the count is 322. Again, 3, 2, and 2, right? So that's that idea of regrouping. What I'd like to shift to now is back into the base 5 pieces. So go ahead and grab your base 5 pieces if you have those available. And we talked about these earlier, but I will remind you of what they are. So we have our long flats, or flats, our longs, and our units. I'll try to make these about the same size. There we go. Right, so we've got 4 different groupings. We've got, and in base 5, they're grouped into 1s, 5s, 25s, and 125s. And again, all those are powers of 5. 5 to the second, and 5 to the third. And so what I'm going to do is I'm going to give you a number, and what I want you to do is represent this number. We'll start with the number 39. And what I want you to do is use your base 5 pieces to sketch the minimum number of pieces necessary to represent the number 39, okay? So use your base 5 pieces to sketch that out. And then come back. So if you've paused and you've done that, what you probably did was you came up with, and you could sketch it out too, was a collection that looks like this, right? And if we start to think about this numerically, what we have is 1 of the 25 pieces, and we add that to 2 of the 5 pieces, and then we add that to 4 of the 1 pieces. Remember, each of the numbers in parentheses is the number that's in the collection, right? 1, 5, 25, or 125. And so what we have is 25 plus 10 plus 4, which is equal to 39. Now, another important thing to consider with this, and we mentioned this a little bit earlier in another video, the numbers out front are telling us how many of each grouping we have. We have 1, we have 2, and we have 4. And so what that means is the number 39 written in base 10 is equal to the number 124 written in base 5. If we want to tell a number that we're writing it in a different base, we just write the base right there. So we can write the word 5 right there down at the bottom. We don't have to do that with base 10. It's assumed that a number is in base 10 if we don't state it. So these two numbers are equal. They have the same quantity, right? With the same quantity of units. 39 units would be written as 39 in base 10, but 124 written in base 5. Why is it written 124? Because of exactly what we showed here. This column is how many 25s we have. This column is how many 5s we have. And this column is how many 1s we have. In base 10, this column is how many 10s we have. And this column is how many 9s we have. Okay, let's try another one of those. So do another one of those. And the number we will do is 327. So again, use your base 5 pieces to sketch it out, and then say, how would I take the number 327 written in base 10? What would that look like as a number using just numerals? What would that look like in base 5? So take a minute and see if you can figure that out on your own. So if you paused and done this, what you probably did was you came up with a visual collection that looks something like this. Again, this is a minimal collection. And what this shows is we have the 125, the long flats. We have 2 of those, 2 125s. And let me scooch this down just a little bit. And then we would add that to 3 25 pieces, these. And then we would add that to, notice how many longs we have. Are there any longs? There are not. So it's actually important for us to note that, right? There are no 5 pieces. It is so important for us to note that. And we'll take a minute, a look in a minute. What would happen if we didn't note that? Plus 2 of the ones pieces, the units. So again, 2 times 125, if we actually multiply that out, that's 250 plus 3 times 25 is 75 plus 0 here plus 2 there. 250 plus 75 is 325 plus 2 is 327, right? 327 in base 10. What is it in base 5? Well, we have 2 of these, 3 of these, 0 of these, and 2 of these. And so how do we write that in base 5? 2, 3, 0, 2. 2, 3, 0, 2 in base 5. Now, why was I emphasizing this so much? If we hadn't written it and we had just done this, if I had just written that, you could accidentally forget that there's a base 5 column and just write 2, 3, 2, 2, 3, and 2. Well, what's wrong with that? This is the ones. If we write it like this is the 5s and this is the 25s, right? But that's not what we actually were trying to represent. Remember the Babylonian system? That was the problem they encountered. They didn't have a 0. We know that this isn't right. We have to have a 0 in here, right? That 0 has to say, oh, this isn't what is supposed to represent. There are no 5s. There are 3 in the 25s column, and there are 2 in the 125s column. So you can see what happens with that 0, okay? As I throw my mouse to the floor. All right, so let's do one more. We're going to work this one a little bit backwards. Okay, so now what I'm going to do is I'm going to give you a number in base 5. So here's the number in base 5. And what I want you to do is rewrite this number in base 10. How would we state this number in base 10? Use your manipulatives to help you with this, and then pause and come back. So the way you want to approach this is, if you're drawing this out and sketching out 430 in base 5, it would look something like this. Because what this number is telling you is that there are 4 25s, there are 3 5s, and there are 0 1s. And that's what this collection shows here, right? What we have is 4 25s. Here we have 3 5s, and then we have 0 1s. So how do we write it in base 10? Well, we have to do a little calculation here. 4 times 25 is 100, plus 3 times 5 is 15, plus 0 times 1 is 0. Add those up, and we get 115. 115. So the number 430 written in base 5 is 115 written in base 10. These numbers are the same. They represent the same amount of stuff, just in different ways, And so what I hope you're starting to see is that this is all about this idea of positional numeration, the position of the numeral within the organization of the symbols really matters, because those numerals, the 4, the 3, the 0, are representing different values. Okay. And just right, we write them from left to right in greatest place values to the smallest place values. And so the last thing I'll just put up here is a final comment from the National Council of Teachers of Mathematics, right? Representing numbers with various physical objects, physical materials should be a major part of mathematics instruction in elementary school grades. This is something that's been learned over time, right? That just using, in the old days, right, we didn't do this. Just using numbers only takes people so far. And I'll challenge you also, let me stop sharing, just talk to the camera. I'll challenge you also, parents, a lot of the times, don't understand why elementary education, particularly in math, is done the way in which it was done. Maybe you've even experienced that if you are a parent. And it's been interesting. I've witnessed that as my son's gone through. He's now in 8th grade, it's important to connect with parents and explain why you're teaching these things the way that you are teaching them, because historically, math, especially in elementary school, was just about how do I find the right answer? How do I get the right answer? That's all it was. How do I get the right answer? Here are the steps. Here's the algorithm. We're going to focus on that more as we move into section 3.2, where we get to addition and subtraction and how those algorithms and processes work the way they do. But what you're trying to develop is good mathematical thinking. It's not all about answer getting. We have tools. We have calculators and computers that can do those calculations for us. What we want to develop are good mathematical thinkers, and we want to develop kids' number sense. We want them to be able to see the things, right? See what the numbers represent, not just do some rote calculation.